Hey everyone, and welcome back to another Unreal C++ tutorial. We're going to jump straight back into our interactable class implementation, also covering the interfaces. So for this, we actually need to go into the character class this time. So if you don't already have this open, just go back into the character C++ class, and we can pretty much get started using the functions that we've had previously. What I've been alluding to in the past is that we're going to use our line trace function we're already doing. As we're tracing forward, we're going to see if we are looking at any interactable classes. If we are, we're going to highlight them. If not, then we're going to make sure that they're all clear and back at their default color. And we're also going to have the option that when we press the interact button, which I think we have here, then we can interact with the class we are looking at. So yeah, we have our interact pressed function. So I'm already losing track of things. First of all, we're going to go to our trace forward implementation. We already have a lot of the logic happening that we want. The first thing we can do is we can kind of get rid of this draw debug box. We don't need that anymore. And we don't really need the draw debug line. We have the crosshair to show where we're looking, and it's going to start getting a little bit busy if we've got all of the debugs on. So we already have the check that we want though, which is whether or not we've hit something, whether we're looking at something. Now, if we are looking at something, we want to find out the information about that class and store that. So what we're going to do is we're going to create a reference to an actor, and we're going to call this one interactable. We're going to say that this equals to the hit.getActor, which is just a function inside of the hit result. I apologize hugely. I've just recorded 2 videos prior to this, and I said that I would be zooming in, and I forgot. I'm so used to typing at that font size. But there we go. Hopefully, I'll leave all future videos at this. Hopefully this is zoomed in enough for people to see. Huge apologies, because I know that I've specifically spoken to people about that. Didn't mean to forget. Sorry again. So now that we have found something, we've hit something, we've got a reference to what it is, we've stored it as the actor we're looking at. What we want to find out is if we have an interactable actor. So we'll say if interactable. So as we're casting around, we're just going to make sure that we've actually got a successful reference to this. Now, because this is kind of done in another if function based on whether we're hitting something, we may not need to do this, but this is just to make sure that as we're doing the further checks, we have a valid reference without giving it any errors back. So now that we have this, we're going to want to account for, in a moment, looking at different objects and looking away. So we're going to want to store a reference to the actor we currently had focused. So up here, I'm just going to say another actor type. We'll say focused actor. In fact, we're going to put this in, if we go over to the header class, we'll go down to just below here. We can make this private because we'll only be using this in C++. We won't need this exposed in the blueprint, so we can put this in the private section. And this is going to be of type actor, and it will call it the focused actor, or currently focused, or something like that. So the thing that we're currently looked at will be stored as well. That way we can come back to the header, and we can say if interactable isn't equal to focused, and also if we have a focused actor. So of course, if it's currently a null reference, then the interactable isn't going to be equal to that, but we also want to make sure that we have a focused actor stored. Then this is where we're going to actually start using the interface. So we say the iInteractable interface, or iInteract interface. We're going to create a temporary reference to this. We'll just call this one interface equals to, and this is where we do our first cast here. So we'll say cast, and we're just casting to the class type, which is iInteract interface. We're going to get a lot of issues here because I haven't included a reference to this. So we're going to go back up, make sure that we include the interactable interface, of course. Okay, so we'll make sure that we have a reference to the interface that we're using. That means hopefully these should go away, and we can call the functions within them. And we just close this off with the reference to the focused actor. So we're looking for the interface on the focused actor. So now if we've found successfully that the focused actor does indeed have the interface, so if interface, then we can call one of the functions inside of the interface. So we'll say interface, and what were we doing here? So this is when we've lost focus. So if we had an interactable, or if we've got a new interactable and it isn't equal to the one we previously had stored, then we want to call the end focus function. And the way that we do that is by saying execute underscore and then the name of the function inside of the interface. So execute underscore end focus, and that will be the focused actor again. Okay, so just outside of here, if that wasn't the case, then we're going to want this function again, but instead of passing in the focused actor, not function, this logic, sorry, we're going to pass in the interactable. And again, we're going to say that if this does have an interface, so we do want that again, make sure we add the open and close brackets there. This time we're looking at a new object, so we now have a new object. So we want to find the interface on the object. I'm going to call the function, so again, execute. And this time we want to say underscore start focus. And again, we're going to pass in, this time we're talking about the interactable. So the newly stored one up here, not the focused actor that we had previously. So we're going to say interactable. Now, of course, this is the first time we've looked at this object. So we want to make sure now that we have highlighted this, we've made this change color. We want to store this as well as our focused actor. So focused actor equals interactable. So down here, at the end of this if statement, so if none of that's true, else, what we want to do is we're going to find out if we have the focused actor again. And I think we can just take this. So this is to account for, again, if we've got the focused actor, and if that focused actor has the interface implemented, and what we're looking at now doesn't implement the interfaces at all, then we don't have a stored actor anymore. Or if we're not looking at anything at all, we don't have a stored actor anymore. So we want to, once again, end focus on the focused actor. The only difference now is that when we've completed this, we also want to make sure we reset the focused actor. So we'll say focused actor equals null pointer, like so. And again, remember, this is outside of the final if statement there. So when it's got to the end of the else statement, we're going to reset this to be the null pointer. So now, once again, the focused actor is not filled. Now, whilst we're using these, because we've got this in the header file, we can also use this in our interact function. So on interact pressed, in fact, again, we can use a lot of this is quite reusable. It's been nice at some point to break this down into a tidier function. But just to get this across, we're going to copy the interact interface using the focused actor. I'm going to go to the interact pressed. And what we want to do is we want to find out, after we've traced forward, if the last thing that we looked at was a focused actor. So if we have a focused actor, first of all, so hopefully we've looked at something, we've stored it as the focused actor, then we want to find out whether or not that has the interface. If it has the interface, then we're going to call the execute on interact, and that's it. So that should now account for looking around, looking at an interactable object, looking away from the interactable object, so focusing and unfocusing, and also actually interacting with it. So once again, with that done, I'm going to go back over to the engine. I'm going to go and hit the compile button, and we should hopefully be able to see this in action finally. Okay, so I've just got one error just here, which is the onInteract function does not take one argument. Okay, so that is, I just forgot to pass in, if you remember that in the interactable interface, we also pass in the object calling it, so the actor calling it, which of course is going to be, in this case, is going to be the character class picking it up. So this is just if you wanted to flesh this out, so you know who has picked it up. So we're going to say this. So this class has called the interact function. Okay, so we'll try that again. We'll hit compile, and hopefully this one works. Perfect. So just with that one change, we now have this working. We can hit play. And what we should expect is that when we highlight over this, it should turn that salmony color. And when we look away, it will be white again. And it hasn't happened. But I clicked on it and we did get our onInteract function. So this will be interesting to find out why this isn't happening. Just going to come in and breakpoint. I'm going to actually run through this on the video to see what's happening and why it's not firing off. Okay, so it's just not even having this called, which means we're going to want to look back into our C++ classes. So as long as this is being called, which is possibly something that I forgot to hook back up, so that could be why. If we go back into our blueprint class, make sure that we have the call to the parent function, because I know that we've been playing about with this. So we have our trace function being called, which means if we very quickly draw the debug line, we just want to make sure that it's going far enough. So I'm going to quickly recompile this. And like I've said, I do like to keep kinds of things included where possible, just to give people a better understanding of debugging and the sort of process of tracking down issues in code. Okay, so we should have our debug lines drawn now. Quite simply, I think at some point then, that was only happening when I pressed the interact button. At some point, I have come into the event tick and I've stopped it from tracing forward constantly, which when you're checking for something like this, we want to do. It could be, now I think about it, many videos ago, I think I removed the event tick function. Yes, I did. So this isn't going to be ticking up constantly and updating constantly because I've removed it. So why don't we fix this? If we go to the public section down here, I think this is where it normally is. We're going to say virtual void tick, and we're going to pass in the float, which I think is usually called delta time. And we want to make sure that we're overriding the standard tick function. We can do a quick implementation of the tick function. So we'll create that. And what I want to do is on tick, I want to trace forward. Okay, so nice and simple. We now have tick back and this should work again. So I'll just go over and compile this. That's all compiled successfully, so we'll hit play. And I'm still only getting this when I click. We can see the trace is only happening when I click, so I wouldn't expect this to work. I would guess that because I've previously disabled tick, I've also came into the code file and said can tick is false, so we'll set this to be true. We'll go back once more. Again, hit compile, this should be nice and quick. The extra length of this video just kind of shows how nice and smooth it can go sometimes. Like I said, anytime I make errors, I keep them in for learning purposes and just so it's easier for you guys to follow along. So you know that I've done nothing off screen, and if you can't get something working, you may have just skipped or missed something, because from start to finish I've got everything recorded. So now we can see we've got the tick running, and if I look at this, we can see that's changed color, and if we look away, we can see it changes back to white. And this horrible spaghetti thing here, it's like uncooked spaghetti, is why I wanted to disable that. So I'm just going to go back one more time. We will disable the debug lines because it just makes it very unreadable what's happening. Now that we know we do have this working, I'm happy to remove those again. So if that compiled, debug's gone. So when we look at this, it turns orangey, pinky, red, back to white when we look away. And of course, if we click and interact, then it will be destroyed and used. Now, the way that this is working, of course, is we have a mixture of implementation. So we've got the on focus happening for the color changes here. Remember, we did include in the previous video our screen debugs. So to get those, we want to make sure, if we want the C++ implementation as well, that is, we want to make sure that we add the call to parent function. And that way, what we should expect is that we'll get our screen debug saying start focus, end focus, and also the color change. So we can see we're getting that just there in the top left. So that's the C++ and the blueprint implementation. Now the other thing is this is another time where we actually need to do a lot more casting and a little bit extra work in C++ than we need to do in blueprints. So this is how we'd cast to find out that we have the interface and then call the function on that interface. Now, like with most things, blueprints a little bit easier because a lot more things are done behind the scenes. So the alternative to this is that we could quite simply skip this trace, call the line trace that we had previously if you've kept this in the blueprint example, and we could basically say that if we have a blocking hit, so if this is true, then whatever actor that we've hit, we want to set the focus. So I'm only going to show the calling one of the functions because it's very similar both ways, but we're going to say start focus. So this way you can see we don't need to even cast to anything. We can literally just call that interface function on the object. So when I said earlier as well, this is safer. We're obviously calling this on the floor. The floor doesn't have that interface, so there's no errors. It just ignores it. Same for the walls. If we now come over here, we can see that we're going to start focus on this. Now, of course, you want to do what I did in the C++. You want to store the focused actor, the last actor, and things like that, compare against them. But this is, again, just an example of how it's so much easier inside of blueprints. You don't need to do the casting. You simply just call the function in the interface that you want to implement. It's nice and safe because, like I said, if it doesn't have that interface, it simply won't call it. It's not going to worry about any null references or anything like that. So just in case I didn't make sense again, because that was a bit noisy with the debug. Again, all of the time that we're doing this event tick trace, we have that logic looking for the start focus interface function. But only when we actually find something which has that interface will it get called successfully. But we can see down here, we don't get any errors or warnings because the floors and the walls didn't have that interface implemented. So this is how you call an interface in Blueprint. This is how you call an interface in C++. You need to actually cast it, and you can make a nice mix and match of both of those to fit the needs of your project. Hopefully that covers all of the basis. It's a really, really useful setup. Interfaces can be, like I said, especially in Blueprints, a lot cheaper. than casting. There's some really interesting talks on the Unreal page, YouTube page at the moment from the recent summit, and some of the talks do go into the difference of how when you cast to an object, you actually get all of the references to any other casts that class might be doing. So you can have essentially from one cast you could include almost the entire project if you've been untidy with what communication is happening in certain blueprints. Whereas this, with interface interactions, it doesn't need to know anything at all about the other class. It will just fire off whether or not it has that interface. If it does, it will call the function. If it doesn't, then it won't. It doesn't need to know anything about the class itself, which makes it a lot cheaper, at least if used properly, and casting can, like I said, go out of control in blueprints. With that done though, I will hook this back up, because in the future, if we do any more with this, we'll probably use the C++ function, just because we've already done all of the logic to store the previously focused actor, the currently focused actor, and the end and start focus, which, like I said, would be quite easy to do in Blueprint, but we've done it once already. So I'll leave that video here for now though. That is pretty much interfaces, I think, covered in its entirety. Hopefully, like I said, that will help you whether you want to work with blueprints or C++ with these or both. You now know how to call these functions. So I'll leave that video here for today. As always, if you enjoy these videos or find them useful, please do leave a like and share the video around. That always helps. Don't forget to hit the subscribe button to be kept up to date with any of the content coming from any of the playlists on the channel. And as ever, thanks for watching, and I will see you all next time.